Hello to all. This is Dr. IJR initiating online lecture series on operations research. Today we are going to learn about the most interesting topic of assignment, that is traveling salesman problem. Let us start with one problem and we can learn how to solve this problem and what is the actual theme of traveling salesman problem. So let us start with this problem. See, a book salesperson who lives in Kochi must meet four customers once in a month located in Bangalore, Pune, Bhopal and Lucknow. The following table gives the distances in kilometers among different cities. See, in this case, Kochi, Bangalore, Pune, Bhopal, Lucknow is given, and if you observe this problem, the row names and column names both are same. So that means if what is the theme of this problem is a salesperson living in Kochi, he must visit all the remaining cities only once and return to his hometown Kochi. So that is the theme. And in the matrix, here the kilometers are given. Say Kochi to Bangalore, 550 kilometers, approximately 550 kilometers. Kochi to Pune, 1290 kilometers. So approximate kilometers were given here. And if you observe that Kochi to Kochi, there is some restriction is there. That means he started in Kochi and when he reached to the Kochi is once he meet four customers located in different cities. After that only he must visit to his hometown. That's the reason Kochi to Kochi restriction is there. Bangalore to Bangalore restriction. Pune to Pune restriction. Bhopal to Bhopal restriction. And Lucknow to Lucknow restriction. So this is observed as a restriction problem also. Let us see how to solve this problem. So for any assignment problem, we have to use Hungarian method only. That is one of the most accurate methods of the assignment problem. So before starting with this problem, first please see my previous videos on restriction case and degeneracy case because this problem may fall under the category of the degeneracy case. So please see my previous videos. And what is the algorithm of this problem is, see, this problem requires 15 steps to get the payoff matrix. So this is the algorithm table I prepared. So just you can do this problem in the rough notebooks. So this step requires step 1 row minimum, step 2 column minimum, step 3 assign. So once we assign, we can get the degeneracy case. So once we get the degeneracy case, simply we can do tick mark for unassigned row like that. And step 5, step 6 not required. Step 7 is there assign. And step 8 tick mark. Again we can get the degeneracy case here. So that's the reason again we have to use the tick marks like this. So step 9 and 10 not required for this problem. Step 11 directly assign. Again we can get the degeneracy. So we can directly move to the step 12. And after that 13 and 14 not required because all rows and columns are having the zeros. So we can directly assign. So at step 15 we can get this matrix and see that all rows and columns are having zeros or not. See, all those are having, yes, all those and columns are having zeros, we can assign. So step 15, assign. So how can we assign? Concentrate on single zeros. See the first row, there is only one zero is there, we can directly assign here and see there is one zero in that column, strike off that zero. Bangalore, yes, there is one zero is there, we can strike out the remaining zero. Pune, there are two zeros, Bhopal two zeros, Lucknow two zeros. So it's not possible. So here Kochi, Bangalore, Pune again two zeros, Bhopal two zeros, and Lucknow two zeros. And if you see again, if you see the row, there are two zeros, two zeros. So based on this basis, so we have to take one assumption. So Pune, out of these two zeros, we can mark any of the zero like this. I guess I'm taking this zero, so strike off this zero and this zero. Bhopal, no, there is here 1 0 is there. I can strike off this one, and finally I can do this one. So the assignment completed. and check that whether it is a degeneracy or non-degeneracy. So number of rows 5, number of columns 5, and number of assignments also 5. So it is a non-degeneracy case. So as per Hungarian method, the problem completed. So we reach to the optimal solution. But before that, check that whether optimal solution is not necessary to this problem. Optimal route is there or not, we need to check. That means, so what is the actual thing is a custom a bookseller stays in Kochi, he must visit the remaining cities. So that condition is satisfied or not, first we need to check. So I will say I will take with Kochi here, Kochi. So Kochi to Bangalore. So first we visit to Bangalore here. So again Bangalore to Kochi to Bangalore. So he stayed in Bangalore and now he started from Bangalore to which city? Again Bangalore to Kochi is there. Bangalore to Kochi. So where are the other cities? So Kochi is the hometown. First he visit to the Bangalore and from Bangalore he return to the Kochi. So this one is not optimal route. He must visit all the cities only one time. So where Pune, where Bhopal, where Lucknow. So that means it is not an optimal route. So for that purpose, we have to do one more process. Step 16. For the same problem, step 16. See this, in this case, assign try with 80 other than 0 as least number. So up to this one, so we thought that 0 is the least number, but in the transportation point of view, if optimal route is not identified, so we have to take the next best number after 0. So what is the next best number of the 0 is 80. So now treat 80 as a least number. But if you see in this matrix, there are two 80s are there. So as a confusion factor, so which 80 we have to take? So first 80 we have to take. So now 80 is the least number, but don't take this 80. So we have to take this 80. And now assign. So I am assigning Kochi to Kochi 0, 80. Out of this, 0 is the least number. That is okay. But now as per this one, so we have to take 80 as the least number. So I can assign 80 here. So already assigned. This one is completed. But don't strike off 80 here because we treat 80, this 80 as a least number, not this 80. So that's the reason don't do any type of practices on this or experiments on this. So 80 Pune already assigned, so remaining zeros we have to cancel. And Bangalore second one, yes, we can directly assign here, cancel. Pune 2 zeros, Bhopal, actual 2 zeros, 2 zeros like that. So column process, Kochi, Bangalore, so yes, Bangalore 1 0 is there. Bhopal 2 zeros, Lucknow 2 zeros. So again row process, Bhopal, yes, 1 0, and the remaining Lucknow 1 0. So again assignment completed. So 5 assignments completed. Now it is an optimal route or not, we need to check. So first one, Kochi is the hometown. Kochi to where he went to Pune. Yes, now he went to the Pune. So he stayed in Pune. Now he can start from Pune. Pune to which one? Bangalore. So now Pune to Bangalore, he stayed in Bangalore, and from Bangalore to which one? Again Kochi. So where about where Bhopal and Lucknow? So that means it is not optimal route. It is not an optimal route. So that means he visit only two cities. Where about Bhopal and Lucknow? So that's the reason it is not an optimal route. So again we can go to the next step, step 17. So assign try with another 80. So actually in thought there are two 80s are there. So already we did experiment with 180, but now we have to do experiment with another 80. So there is one more 80 is there. Now we can treat this 80 as a least number other than 0. So start with Kochi. So Bangalore. So now this 80 we can directly assign here. So cancel this one and remaining also. So Pune 4 zeros, Bhopal two zeros, two zeros. Kochi, only one zero is there, so we can directly assign here. So column process 1, 1. So we have to strike out the remaining zeros. So Bhopal and Lucknow. So again we need to check whether it is an optimal route or not. So I can write here Kochi to Bangalore. So he started from his hometown and stayed in Bangalore, reached to the Bangalore, stayed in Bangalore. Now he will start from Bangalore to which city? Pune. From Pune to which city? Kochi. So again where Bhopal and Lucknow. So that means it is not an optimal route. It is not an optimal route. So now we move to the step 18. So already we got that two 80s are there as a least number. Now after 80 we have to take the another number, the next best number after 80, that is 1200. So see, 1200 is the next best number after 80. Now we can treat this 1200 as a least number other than 0 and two 80s. So now start with this 1200. Now directly assign here 1200 and remaining we can cancel the remaining zeros and here also. So Bangalore 10, Pune 3 zeros are there, Bhopal 2 zeros. So Kochi already completed, Bangalore already completed, and Pune there are two 80s and 0 is there. So we have to consider here. We have to consider because there is no more 0 here. That's the reason we have to don't do any practice here or experiment here and see the Bhopal here. So Bhopal there is 1 0 is there. So we can strike off this 0. And if you see that Kochi, there is 80 is there, so we can select this 80 and cancel the remaining 80 and 0 in that. And finally, there is only 1 0 is there, we have to take this 0. And see, there are 5 assignments are there. And now check that whether it is the optimal route or not. So Kochi is the hometown, Kochi to Pune. Next one is from Pune to which city? Bhopal. So now he visited to Bhopal and now he started from Bhopal to Lucknow and Lucknow to Bangalore and Bangalore to Kochi. See, he visited all the cities 1, 2, 3, 4, remaining 4 cities and finally he reached to the hometown, the Kochi. So this is optimal route. So now the problem completed. So this is the way to solve this problem and finally we can do one more process here. Take the original table like this. So this is the original table and we have to prepare the table like this. So Kochi to this one Pune 1290 kilometers. Next one from Pune to Bhopal 785, Bhopal to Lucknow 665, Lucknow to Bangalore 920 and Bangalore to Kochi 550. So total travel distance is 5210 kilometers per month. So this is the way to solve this type of problem. So this is one of the most interesting problems of assignment problem. I hope all of you understand about this problem. So let us do some practice. So you will get expertise in this type of problem. So thank you for watching.